All right. I think it's recording now. All right. So, uh, in terms of history, now you probably are going to laugh at this, but we can divide the history of robotics into kind of, I would say, fiction and non-fiction, or probably fiction and industry. Right? In terms of industry, what is the history? In terms of fiction, what is the history? Because uh, part of robotics is, I mean, the idea of robotics or robots, generally speaking, comes from fiction. We imagined that. We thought about having something that can do or work or can help us with doing things. And then we started, I would say, scientifically trying to make it happen. It's similar to a lot of other things, I would say, probably, even if you look at the history of space travel. We imagined or we wished for things, and then later on we decided to make it a reality. So that kind of goes in. That also is true about robotics, right? The whole field. Uh, we imagined it, and we decided to make it a reality. So if you think about robotics, let's talk about, I would say, some of the movies. I guess the most famous one that not even my generation, couple generations before me, know is the character in, I don't know how many of you actually have seen the movie Metropolis. It's a very old movie, I think 1926, 27. There's a character there, Maria, and she probably is pretty, I would say, I don't think that's the first character that is considered as a robot in a movie, but it's one of the first ones. And basically, the way they made the movie, obviously, at the time, it's just a human in a suit acting like a robot. I don't need to mention the most famous ones. Every generation knows those from Star Wars, right? C3PO and R2D2. So, everyone has some, I would say, probably memories of those, even from old versions of Star Wars movies up until the new ones. So these are, I guess, these are the most famous robots in movies. And we're talking about 1970s, and obviously at the time, again, same story. They were just humans, like actors wearing a suit, acting like a robot. There was no really a robot within functioning, a functional robot or anything like that in those movies. And those characters were basically just benign robots. They were intelligent. They had some engineering skills. They could do a lot of things, right? That's at least how I remember R2D2 and C3PO. You can dig much deeper into movies and animations and Wizard of Oz. If you think about it, we had actually a robot, or the Tin Man. You can think about it as a robot. So you can dig deep into movies, and you can find a lot of characters in old movies when there was no even such a thing as a robot. Now, if you look at I would say, literature, more about books. If you look at books, I believe probably the most famous author, an American author who wrote about robots, is Isaac Asimov, right? Asimov, or I probably am saying his last name incorrectly. Two most famous books that he wrote, The Caves of Steel, and I believe the other one was Robot Visions. He also had a book, I think, because that's the one that he comes up with those rules. So I think it's Run Around. Maybe I have to double check that. You can always Google this. So he's the one who wrote a lot about robots, but the word robot itself is actually a Czech word, right? The country Czech, and it basically means that robot means it's something like worker or a slave, right? And And this word actually was created, or I guess the technically speaking, it was coined by Carl, if I remember his last name, Capek. Carl Capek. He was the one who coined this word robot in 1920, and it was in a play he wrote. I do not remember the full name of the play, but the abbreviation or the short word was RUR. That was the title for the play, and the theme was pretty much similar to typical movies about technology you see nowadays. Like, there were people created robots to do their everyday work, and then robots got to uh, basically there was, I don't want to say revolution, but robots tried to retake their like basically change their role, and they rebelled, and they started killing human beings. So it's like that kind of theme in the play. This was like 1920. So that's the play that the first time the word robot came, I would say, into existence. And the story is like very similar to, again, you've seen that story over and over in different movies. Now, again, sticking to books and fiction part of the uh, story is uh, Asimov, right? It's Isaac Asimov. He, in his book Run Around, he was the first person who basically created or introduced laws of robotics. Now, these laws are not really laws. It's not like laws of motion from Newton or anything like that. It's more of a moral code for robots, I would say. I don't know if you've read any book by him. If you haven't, I suggest definitely. It's a pretty interesting fiction. The typical rules. So I can give you just simplified version. Don't quote me on these. The first one is the robot may not injure or hurt any human being, right? Through what he's doing or his interactions. So a robot is not allowed to do that. The second one is the robot must obey any order as long as it doesn't break the first law, meaning that it doesn't hurt humans. So these are like, again, a little bit of piece of history. And the rules were coined by him that, again, more like moral rules. And I think the third one is pretty much is a robot has to make sure that it is protecting its existence as long as it does not break the first two rules, uh, as long as it's not against those two. So these were like the first initial thoughts of laws of robotics that I would say, again, moral codes rather than anything to do with robotics. Now, this is all fiction, books, and this kind of stuff. But you can also look at the industry. Right? What happened there? It's more serious stuff. Now, I think I brought my slide. Okay, so this is all of history. I believe looking at some pictures are much more helpful than me just talking here and explaining things about these in industry and what happened. Now, when you look at the history of robotics, right, whether it's fiction or it's industry, the thing is, robotics is kind of inseparable from the history of computers. A lot of it, because we'll see later on, I'll emphasize that. And you have to keep in mind that robotics is a multidisciplinary field. Right? Now, we are mechanical engineers. We only look at the mechanical engineering aspect, a part of mechanical engineering aspect, I would say. Just we look at how they move, the kinematics, if we get time, a little bit of dynamics of robot arms and how they are controlled later on. If you take control course, you will become more familiar about how to control a stepper motor or a specific kind of electromagnetic system or electronic system. That's a little bit more towards mechanical engineering. Now, there is a computer science aspect to it, how to code a robot, how to make a robot do what you want to do given a specific condition. Right? the whole field of artificial intelligence and machine learning is adding a lot into robotics nowadays. That now you have a machine that is supposed to be working independently and makes decisions and can make this, should be able to make decisions independently. How do we figure that out? So the field is vast, and a lot of things can fit into this. It's not something that one engineer or one type of engineer can uh, go from 0 to 100. You can familiarize yourself with different aspects and be uh, very good at aspects that are related to mechanical engineering, but the field is multidisciplinary. So the history of robotics, I was trying to say, also includes the history related to computers. How did programming, how did we start programming machines? Because robots are supposed to be programmable machines that can actually do tasks for us. So all the way back, right, there were these machines, called them automata. These machines were basically, we were talking about in 18th century, 18th century, from beginning till mid 18th century. There were these machines that were basically a bunch of gears and cams and belts, and they were trying to mimic what live animal or what a person does. Right? The famous one that I would say it's worth mentioning is the digesting duck. Right? Now, invented by this guy who was a French scientist. I tried to say his name, but most probably I say it incorrectly. Uh, if you want to go with French, or probably I'm just going to butcher it in French, Vukansa or something along that line. Vukansan, maybe that sounds more French. So digesting duck, what was it? It's basically just a duck. Right? You feed it some pellets, like feed the duck some pellets, and what happens is the pellets go through a bunch of gears and cams and belts, and comes out as waste. So it's trying to mimic the what a duck does, eating and basically creating waste. But what it was basically, it was a clockwork machine, right? As I said, it filled with pellets. It appears that it's eating, and after passing through some digesting system or whatever you want to think about that as digesting system, and eventually comes out of waste. Very lifelike machine, could eat and produce waste. Now I put the link there if you want to actually see. I can try to open it. They rebuilt it in some museum, I believe. Let me see. I should be able to share my computer sound. Let's see if it works. The video has a sound, so I'm hoping that by clicking on share sound, you're actually hearing this. Yeah, well, all right. Let's close this. So not that much of an interesting stuff. And you might ask, what is the use for that? Nothing. They just are trying to make something similar to lifelike, I would say lifelike machines, best word for it. If you want to know more about the details in the system, I actually put a link to the PDF that describes all the cams and gears with pretty good detail how things work there. You have a weekend, you want to look into something ancient, this is a place to go. Now, well, pretty useless, right? Now, a little more useful is if we go jump, I'm giving you glimpses of history, obviously. A lot has uh, happened in between. Jacquard's loom. Now, this is something that was actually useful. It's an invention of basically controlling the weaving pattern, a machine that basically does weaving for us. That was the first machine that they could actually code that. So it's more like a form of automation. And it was programmable. As you see, these small punch cards there, these are basically, this is a program that they put, and then they run the machine, and the machine, you still need one operator for this machine, and it creates the pattern that you want. It weaves. So it was like the first, I would say, useful type of programmable machine, automated machine. I also put a link there to a video, so I won't go over the video, but I put a link again as part of a museum, so it's in Scotland. Um, you can read through the detail of the machine, and there's a good video showing this person actually uh, operating the machine. I'll leave it to you. It's a relatively good explanation about what is happening there. Um, and again, as I said, you'll still need one person to operate the machine, but it was a pretty good invention, right, for that time. All right. Moving on, we go to after mid 18th, 19th century, so 18, probably 17, yeah, 70. So the analytical engine. Now, this actually not an engine that was built. It was never built. It was invented by, or I would say proposed. I mean, invention is the right word. He never built it. By Charles Babbage. He was an English scientist, or I would say it was an English person. I'm not even sure if it was a scientist, if it fits into that category now. It was more like a card-controlled computing engine. Like the same cards that you saw that they were using, not same cards, but similar idea that they were using punch cards to program that Jacquard's loom. Now here we have a machine that used cards for computing. Now he didn't have the technology to build it. Right? He just invented the notion of a general purpose computing engine. Right? And the computation that it performed was basically dictated by a program. So you can think about it as a very first version of a computer. Right? You have a machine as a computing engine that you can program it. It's general purpose. You can program it to do computations for you, and it's programmable, as I said. Later on, it influenced electronic companies, like electronic devices. Like the machine ENIAC. I don't know if you guys know about that. It was built during World War II to break the codes. Basically, it was the idea. I would say this is probably the initial idea of building such a machine. Now, the reason we talk about this as part of the history of robotics, because we can think of robots as computers, right, that can do things to the physical world. Right, a computer does things in its own world, programming, coding, making computations. You can create things in its own world. We can think of a robot as a computer that can do things to the physical world. Right? So that's kind of an integral part of what was going on. So this is about the programmable machines side of the story. Now, right? That was the initial thought and notion. If you go forward, 1949 or about that time, this is after World War II. Right? Argonne National Laboratory that still exists, and does pretty interesting research there. They do pretty interesting research there. So Argonne National Laboratory introduced this idea of a slave master manipulator. Now, what is this? Pretty simple nowadays if you think about that. What let's start from here. What was the problem? The problem is they wanted to assemble nuclear, I believe, weapons. Right? Now, they had to handle radioactive materials. And obviously, it wasn't safe to have a person in the room as radioactive materials are. So they needed an idea to how to do it. So they came up with teleoperation, as they call it sometimes. Teleoperation. How does that work? Well, you sit in one room, or the person who's doing the operation sits in one room, right, and has the manipulator arms. Grab the arms and move them. Right? And then slave arms in the other room, they move. And through the video cameras they have in the other room, they see how it's moving, and it's exactly moving the same way they want it. And they the person in charge modified the motion to make sure that the same operation is happening, right? Same operation is going on. So it's important because basically this is a technology precursor to modern, I would say, manufacturing robots. Right now, in your mind, replace the person sitting on the master manipulator side with a computer. If you replace that person with a computer, which is programmable, then you're going to have a set of arms that can do whatever you program them to do. So this is it was a very big step, right? All you needed to do is that next step was to just replace that person with a program. And there's a link for a video there. For some reason this video jumps. Actually, it shows a pretty old video, I believe. That's
to succeed in the autonomous vehicles industry, you need data engineers and connected infrastructure.
Let's see if it has a sound. It doesn't have a sound, so I'll leave it like this. But it shows pretty much what I told you that was happening. This is 1949. Obviously, it's a demonstration. They were not using it to make or pour tea or coffee, whatever. It does look like tea. But this person is in a different room, operating the master arms and the slave arms in the other room, doing whatever. But that's pretty risky. I think they wanted to show how accurate it can be. So again, pretty important progress because, it's 50s, 40s, so smoking was, I guess, encouraged at the time. That was a pretty good step because, again, as I said, just replacing the person with a programmable machine, and you got yourself a manufacturing arm, right? And that's pretty much what happened. If you go to the next big thing in robotics, is basically the start of Unimation company, first industrial robot that was designed and manufactured by Unimation Incorporation. Right? It's basically universal automation. Right? That's the name they put together, Unimation Incorporation. Now, it's founded in Connecticut, right? And it was the first company producing industrial robot arms. Now, I think the company started in 1956, but I believe the first one that went to a manufacturing site, which was GM, that happened in 1960, beginning of 60, so 61, 62. The first manufactured robot arm, or better to say a programmable robot arm, went into manufacturing environments. So that's a little bit about the history. And then from there, a lot of other things happen. Obviously, robots today are a little bit of different story. Right? I'll talk about those robots today a little bit in the next class, and then we start talking about our topic. But I also put a video there. Again, just this link to the video showing that basically
in the early 1950s.
This one has a video, so let me share the sound. Yeah, George Devol was actually the person who's pretty famous, was the inventor of, he did it along with...
In the early 1950s, most Americans were captivated by imaginary robots.
I'm hoping that you hear the sound. If you don't, say something in the chat box.
We could hear the sound.
Was inventing the first real one.
To try to get a normal businessman to understand a robot, he thought you're talking about science fiction or something like that.
A prolific inventor, DeVol had already introduced the world to the Phantom Doorman, the first automatic door. But his 1954 patent filing opened the door to what DeVol called universal automation, which led to the world's first industrial robot. The patent was the easy part. Finding a business partner seemed impossible until DeVol met entrepreneur Joe Engelberger.
Talking about it, I said, gee, that sounds like a very good idea. I think the patent makes sense to me.
The two men formed Unimation, the first robotics company, and in 1961 introduced the world to a new kind of worker.
Automation's newest contribution to man. This jack-of-all-trades robot is called Unimate, and it handles dull, difficult, or dangerous jobs with equal aplomb.
Weighing in at 2,000 pounds, Unimate's flexible mechanical arm was powered by hydraulics, its memory a large magnetic drum that enabled it to master dozens of different operations with its end effector, or robotic hand.
The end effector is another word for tooling. Now, the tooling can get pretty sophisticated because some of the tooling has sensors built into the clamp, let's say, that will allow it to exert just so much pressure on something.
Unimate could grip, weld, drill, and spray, but company executives were hesitant to commit, and workers initially afraid of losing their jobs.
The robot had one thing advantage immediately, and that is the robot can work 3 shifts or work 24 hours a day.
But eventually, executives saw the competitive advantage of robots, and workers found thousands of jobs in making them. Today, industrial robots perform millions of applications throughout the world.
All right, so that's so I'll talk a little bit more about today's robots and the way they classify them, at least briefly for a few minutes in the next class. But that pretty much sums up the general idea. And in this course, this is introduction to robotics. So we'll be mainly focused on just the robotic arm and how to study its motion. Think about dynamics we have. Now we are looking at kinematics mainly. We may or may not get to talk about dynamics. Kinematics of a robot arm. How can we study the motion? And knowing that, how does that help us to plan the motion? I'll say you have a robot arm, you want that robot arm to grab something. They mentioned end effector. You have some kind of arm as the end effector. You want that robot arm to pick something from here, like a simple pick and place, and put it somewhere else. How can you design this path? Right now, designing the path is what we're focused on now. Remember, there are multiple layers. Once you design the path, you have to know control, you have to know electronics to be able to code that path into your machine and force it to do what you want it to do. So we're going to be focused on that, right? Kinematics, how to design the path going from one place to another for every joint in the arm. If the arm has multiple joints, has multiple links, I'll introduce the concept of links and joints and end effectors next class. So don't worry about that. But that would be the focus of our course. A lot of, again, as I said, we're going to have a lot of, you probably are going to force to use a lot of imagination, using different coordinate frames, how to go from one coordinate frame to another coordinate frame in three-dimensional space. We try to formulate it in a very understandable way, but it still needs some good effort into thinking in three-dimensional, right, in your mind. So sometimes you're going to end up trying to figure out how to convert. Now, what happens is that in a lot of examples I solved during the class, to basically elaborate of the whole kinematics of the robot arm is we need pictures of robot arms. And I can't draw them. Now, in a typical course that was not in remote mode, I was always printing those pictures as handouts and bring them to class and distribute them to everyone to have it while basically putting it on a projector and going over how to basically figure out the kinematics. We don't have it anymore. So I put the pictures on my slides, right? For examples, for these examples, and I go over them, and I post those pictures. Let's say I want to look at a specific part of a robot arm. It's a little complicated. I can draw that. I have to spend the whole class drawing it. I post whatever you need to have for that class before the class on Moodle. So before the class, if you log in, you'll see, Danevet Hartenberg example 1, and there's a PDF file with a picture, with 2 pictures. Now, I used to do it so students can print it. I will print it and bring it to class also. But now that we're remote, I'll put it there. If you have a printer at home and you're taking notes, print them and write on those, basically draw whatever, write whatever, or follow my steps on those pictures or figures. If you don't and you don't mind, and you can just take a look at my notes later on or video lectures. And obviously they are going to come with those pictures. All right, I think that's pretty much all for today.